Right, guys, welcome to the lecture. And I think in the previous lecture, we have seen only the basics of array. We have not seen anything big, just the basics of array, how array can be declared, how values can be initialized, and how using index, how we are going to access all these things only we have seen. In the memory block, how array is stored, only these things I have shown you. One thing that I left in the array is that I need to show you one more thing. For example, if I just declare an array of size 5, for example, and I have to store, I'll be storing, for example, I told you that this place itself you will be able to assign, right? So what I will do is I have taken 5 block, and 5 block, what I have to do, 5 elements. But there is no necessity that you have to give 5 elements. You can also give uh, two. I'm just giving only 3 elements, 2 elements shortage. 2 elements I'm not providing. If 2 elements are not provided, then we will just check what will be happening. Okay, so now just for the sample, just for the demo purpose, I'll just print what is there in a of 2. What is there in a of 2? In the second index we are having the element called 4, because the very first element belongs to 0th index, next element belongs to 1th index, and the next element belongs to 4th index. Okay, just by saving this, I'll just show you the background process. I'll show you the line by line process happening inside the compiler. Fine. So can you able to see here, one activation area is created in the stack, and one block for A with 5 blocks inside is created, and all these numbers are having some random values. So let me execute this fourth line. Fourth line is executed. Can you able to see the first 3 elements are allocated with the respective element that I have given, and the remaining 2 elements have become 0. So what becomes is that if you at least assign one value at the time of declaration itself, when you assign 1 or 2 values, all the remaining values will become automatically 0. By default it will be garbage value. But if you assign at least one element, don't go to 3 elements. If you assign only one element, that 0th index element will be assigned to, and all the other elements will be assigned to 0. Okay, so suppose if you want to assign okay, so that we will just, I'll show you that also. For example, I am just assigning only 2, and we will check now. We'll check now here. So if you see, it's random elements are only there, 40505, some garbage values. Suppose if I execute fourth line, first element is changed to 2, but all the elements, if you see, these elements are changed to 0. So once you assign at least one element, and all the other elements will be changed to 0 only at the time of declaration. I'm not telling like this. If you do like this, okay, I'm not telling like this. Okay, so if you do like this kind of initialization, a of 0 is equal to 5. If you do like this, this is not going to assign all, this is not going to change all the other elements to 0. Only this kind of declaration, the declaration that comes along with the initialization, that comes along with the declaration, this only what it will do. At least one element, if you assign, all the other elements will become 0. So if I want to allocate all the elements to, if I want to change all the elements to 0, what I can give? I can simply give 0. So what will happen? The 0th index will be stored with the 0, and automatically all the elements will be converted to 0. So if I give like this, what will happen? All the 5 index element will become 0. It does not mean that this 0 is allocated to all the places. No, this 0 is allocated only to the 0th index. All the remaining index are changed to 0 automatically. Okay, so I can also show you that. Okay, just let me stop, and I'll just show you again now. So now, because of this implementing 0, okay, here extra bracket I have given. Okay, just let me save. So if you see, again random values are there. So if once I execute, all the index elements have become 0. Okay, fine. So this is one thing that I left, the basics of arrays. Okay, so now we will just enter into structure. Okay, I'll just stop this process. We will enter into structure. What is the structure? First, I will just go with implement. I mean, to the just general explanation, definition. Then I'll just tell you manually for what reason we have to go for structure. Structures are collections of data members. Data. It is also collection of data. So we generally say that the collection of data member of related under one another, of related data member of related under one name, and the data type can be similar. The data type can be similar or otherwise dissimilar also. This is one kind of advantage. What we are saying, collection of data member of related under one name, and those data can be either of similar data type or dissimilar data type. Coming to array, we said very clearly that it can be of the same data type. If I want to cluster 5 elements of the same integer data type, then I can go for array. If I want to, for example, I'll just tell you a few examples. For example, you can just take array. You can just take mark of a student. We know very well that a mark of a student will be definitely integer. A particular student can have, for example, 5 subjects. When 5 subjects are there, and each subject will have 1 mark, so you will be having 5 integer values. So when 5 integer values are there, you can cluster it together in array, because all these 5 marks are of same data type. But suppose, I'll just tell you, if suppose if you want to, we'll take student database. For example, if you see student, a student can have a name. He can have name, and he will have, for example, age, and he might have, for example, marks. Okay, then CGPA, address, and many other data also. For example, we'll just take these 4. For example, if you take names are characters, collection of characters. We call it as strings. It's a different data type. Age will be integer. Marks will be integer. CGPA will be a float value. So all these data are different data type, different data type, but they are of different data type, but they are all related data to a particular entity. They are all data associated with a single entity called student. Okay, so take a object like student, and what are all the details of the students can be clustered together, and that is what the usage of structure is. So related data member can be considered together. I'll just give you a few examples for your better understanding, but this is a thing that I want to convey. Structures are used for collectively store the data members which are related to one another, which are related to the same entity, and they can be of similar data type also, no issues. We will not say that this has to be of different data type. No, same data type also is fine. The same mark can also be taken as a structure, because you have 5 subjects, right? And all these 5 subjects marks are related to only one student. These all 5 subject marks are related to one student. So all these 5 subjects are going to be subject 1, then subject 2, then subject 3, then subject 4. For example, or 4 subjects are there, and all these 4 subjects marks are related to a single entity called student. It is related to one another. So these 4 integer data can be same data type. So these 4 integer data can be also clustered here in structure also. Okay, so but one difference is that in array I will not be able to store different data type collectively, but I will be able to do it here in the structure. But the main motive of structure is not to collectively store different data type. Okay, the main aim of structure is not to store different data type, but to group the related data members. What are related data members? This data members are related data members because these are all related to a same entity called student. Okay, for example, we will just take a example of rectangle. I'll just take a rectangle. This is rectangle. For example, this green color marked is a rectangle. So rectangle is the entity. And what are all the data that is related to rectangle? I think length and breadth. Hope you know this, right? So length and breadth are the two data that are related to this particular entity. So what you can do, you can take this as a structure. How we are going to take this as a structure, that I will show you here. Okay, so a structure has to be defined outside your main function. A structure has to be defined outside the main function. Here in this place, cursor blinking, right? That place. So first of all, you will have a keyword called struct, followed by the name. What is the name? I think these two data member are related to the entity called rectangle, right? So we can keep this entity name as the name of the structure. So we can take rectangle as the name of the structure. Inside this, I will open a body part block, open curly braces and close curly braces, and inside this open and close curly braces, I will enter the data member. What are the data members? One is length, and length will be an integer. I'm just taking it as an integer. So int length, followed by what is one more thing? One more thing is going to be breadth. Fine. So this is a rectangle, and rectangle will have length and breadth which is clustered together inside a structure. So whenever related data members are there, then you can take it as a structure. So now for example, I will tell you, if you take integer will take, for example, we told that either 2 byte or 4 byte based on the compiler. Okay, and one more thing I need to tell you, and this complete definition should be ended, right? So this end should be ended using a semicolon at this place. Outside this close curly braces, next to this close curly braces, you have to give a semicolon. Suppose if you are not giving the semicolon, can you able to see that this bracket, this place is showing error? Because this place is expected to print it is expecting a semicolon. So once you give the semicolon, automatically the error is taken back. Okay, now if I just see integer, you know very well that integer will take 2 or 3 4 bytes. Okay, integer will take 2 or 4 bytes of data based on, it will take 2 or 4 bytes of data based on the compiler. Here, for example, let me consider that integer is taking 2 byte. Suppose if integer is taking 2 byte, then how much memory this entire structure will be taking? How much memory this entire structure will be taking? This will be taking, for example, this integer length will take 2 byte. Let me assume that integer is taking 2 byte. And now this breadth will take 2 byte. So if you add all this byte together, this entire structure will take 2 plus 2 equal to 4 byte it will take. Okay, so this will take 4 bytes. Fine. So this is one thing that you should know, how much memory is allocated. And one thing, while defining the structure, the memory will not be allocated. Only while initializing, only the memory will be allocated. Only during the initialize, if you are declaring some variable using this structure. Suppose if you are declaring any variable using this structure, then only memory will be allocated. This 4 byte will be reserved. Now while you are defining this, declaring, right, in the definition part, definitely it will not be working. Okay, definitely this is not going to occupy any memory. Now it will not allocate any memory. I'll tell you when it will be allocated. So in this video, what I have planned is, I have to tell you how defining structure. It's the first one. The next one is, I have to tell you about the size of structure. How it is going to be the size of structure, based on what we will be calculating the structure of size of structure. Then followed by declaring a structure. And next we have to do how to access the data members. So accessing the member. What is member? Each and every variable inside the rectangle structure is called member. So length is a one data member, or generally called as member, and breadth is called as one data member of the structure rectangle, generally called as member. Okay, fine. So how to access the member inside the structure, how to declare a structure, defining structure, size of the structure. I think we have finished the first two parts. Defining structure. How to define a structure? We can take a entity, and this entity we will have certain related data, and those related data are converted to data member, and the entity is converted to structure. You have to place a semicolon at the end of the definition. So this is completely called as defining the structure. And size of the structure, whatever the member is, each and every member's corresponding how much memory will have to be taken, and it has to be added, and the total memory is what the memory allocated to rectangle, and that is what size of the structure. So what is the size of a structure? Size of the structure is sum of the size of each and every data member. Okay, so size of the structure means it is sum of the size of, okay, sum of the size of each and every data member. So 2 plus 2 4, it is what size of a structure. Now the next thing is we will just come to the part of declaration. Okay, how we are going to declare it. Okay, so I'll show you here itself. How I will be declaring is struct keyword followed by the name of the structure that you have provided. So now what I have to tell you is that similar to integer, now this entire word, okay, similar to integer data type, now struct rectangle itself becomes a keyword. And it becomes a new data type that a user has defined. You have defined, the system has not defined. C language is not defining, you are defining a new data type. So that this is called as user defined data type. I think in the data type section I have shown you certain classification. Among those classification, one classification is user defined data type, and inside that only rectangle and union was coming. Okay, so not rectangle and union, structure and union was coming. So this is a user defined data type. We are defining a data type. Okay, so now what happens? My struct rectangle, the keyword together, struct rectangle itself becomes a data type. So first of all, whenever I want to declare a variable, what I need to do, I need to specify the data type of the variable. What is the data type of the variable? Struct rectangle together is called as a data type. So now data type, with this data type, can I declare a variable? Yes, let us declare a variable called R. So I told you that when I'm defining the structure, memory will not be allocated. Now whenever you are declaring a variable, here only memory will be allocated. Now only memory will be allocated. Memory is allocated now. How memory is allocated, that I will show you now. How many members are there for rectangle? Only 2 members are there. So let me show you here. For example, these 2 blocks are allocated. For example, I'll just show you these 2 blocks. These 2 blocks, consider that these 2 blocks are allocated. Okay, so first block will tell you, it is referred to the member called length. This first block is allocated for length, and the second block is allocated for breadth, and these 2 blocks are consecutive blocks which is allocated. So this entire thing is called as a struct rectangle, and this entire memory block is given the name called R. This entire memory block is given because I always I am again and again telling you, variables are the name given to the memory block. So for struct rectangle, what you have done, for struct rectangle, you have created a memory block. In that memory block, one part is length, first data member, second block is breadth, is the second data member, and this entire part is given the name called R. This memory blocks, both these memory blocks are given the name called R. Okay, so now the next thing is we will just go with we have done declaration. Right now we will go with initialization part. Okay, so now I'll just come here. This part can be called as declaration part. This is called as declaration. And now I'll just show you one more way of doing the declaration as well as the initialization in the same line itself, as I showed you for the arrays, right? I showed you for the array. How I showed you for the array? I showed you like this. Okay, int a of 5 and is equal to open close curly braces 1 comma 2 comma 3 comma 4 comma 5 semicolon. This is the way I told give you, right? Declaration as well as initialization, both are coming in the same line. Similarly, here also this can be converted to, this is declaration and initialization can be given like equal to open curly braces close curly braces, and for example I'm planning to give 10 comma 5. Now what will happen? Your first member of the structure data type is length. That length block, that length data member is allocated with 10 and breadth is allocated with 5. Okay, so now what happens automatically when you give like this R block is created, and in the length block 10 is stored, and in the next block breadth block 5 is stored. Okay, fine. So now this is declaration as well as initialization coming in the same line. Suppose I'll just comment this. Suppose if I want to do the declaration and initialization separately, like in array. In array, what you did? In array, you declare in first line, and also what you do in the next line, a of 0 is equal to 10, and then a of 1 is equal to 10. You did your initialization like this also. Am I right or wrong? Yes. So I told you that this is the way to access the array element, and this is called as, the entire part is called as initialization. So declaration is happening on the separate line and initialization is happening on the separate line. So like this, similar to this, I will show you one more way in rectangle also, sorry, structure also. So first of all, I have to declare a structure rectangle, and variable name is r. And now if you see, variable r dot length, where dot is the operator which is used to access the data member of a particular structure. So r is a variable of the structure, and using r I can able to access the member of the structure. So what will happen now? R dot length is equal to 15. Then r dot breadth, I'm accessing the next member and I'm assigning 10 to it. Okay, so using this dot operator only, what we are going to do, we are going to access the member of a structure. You might think that while I'm assigning these values, automatically these values are assigned here. No, the values are not assigned here. The values are assigned to the new memory block which is created, this block. In this block only memory is, the value is stored. So for example, r dot length is equal to 15, r dot breadth is equal to 10. What will happen here? Automatically this will be changed, 15 and 10. Suppose for example, I take one more rectangle, and the name of the rectangle is, for example, I'll just take temp. And now what I will be doing is, I can see whenever I declare a new variable like this, what will happen? A new block will be created. For example, like this, a new block will be created like this. And this is a different block. This block and the previous block, this r block and this temp block, both are different block. Both are not having any relation. First block refers to the length and second block refers to the breadth. This block refers to the length member of temp. This block refers to the breadth member of temp. This block refers to length member of r, and this block refers to breadth member or r. So both are different. So now for example, if I give temp is equal to 3,8, what will happen? This new block which is created here, 3 will be stored and here 8 will be stored. Yes. So now I'll just show you the same thing. Okay, fine. I'll just show you the same thing here in this main memory also. I told you in main memory what will happen whenever your main function, which is the entry point, whenever your entry point is starting to execute, what are all the memory block required inside this main block. First of all, a main activation area will be created, and inside this main activation area, whatever the block required will be allocated inside that activation area. So what will happen here, one activation area one activation area for inside your stack will be created. Okay, so for example, one activation area for your stack will be created here in here in the stack, and the activation area name is main activation area. So in the inside this main activation area, what will happen, two block will be created. One block is R, and R will be having two different block, one is length, the other one is breadth. Similarly, you will have one more block called temp, and this also will be having two blocks. One block refers to length, the other block refers to temp. So what will happen when you assign some value to this R will be for assigned 15 and 10, for example, 15 and 10. So similarly, what will happen is the temp will be assigned with 3 and 8 once you assign, I'm telling. Okay, so now what will happen once the entire program is completed, then the activation area, then this entire main activation area will be deleted, and all the code which is stored in code section also will be deleted. Okay, so I'll just show you the background process of the structure here line by line also, right? So if you see here, you have two blocks called R and temp. So first of all, activation area called main is created inside your stack, and inside that activation area you have two blocks called R. Let me expand this block called R. What you're having, you're having two member called length and breadth. Inside temp you're having length and breadth separately. Okay, so it's separate block for R, separate block for temp, and it is having a random value, I mean garbage value. Don't think that any 5 is assigned. No, 5 is not assigned, 4 is not assigned, 0 is not assigned, 0 is not assigned. They are all garbage values. So now I will execute this 15th line. If I execute 15th line, what will happen? R blocks length member will be changed to 15. We will just check. Yes, it is changed to 15. Now if I execute 16th line, then the same R block breadth member will be changed to 10. Yes. Now similarly, if 17th line is executed, what has to happen? The temp length and breadth has to be changed to 3 and 8. Yes. Now once the last line of the entire program is executed, and what has to happen? Then the entire variable section, stack, everything is deleted. Okay, fine. So now if I have to print it, what I have to do? Printf, you have to print an integer value, right? Two integer value. For example, I will just consider %d, comma. If I want to print the length and breadth of rectangle R, then I have to print r dot length, comma, r dot breadth. So how will you access? Using the dot operator. So variable dot the member of the structure that you need to access. Okay, so what we have seen so far in this, so I'll just make a semicolon, and I'll just also show you how we'll just execute and check whether this is working or not. Yes, can you able to see here? R dot length is 15, R dot breadth is 10, both are printed. Yes, so in this section what we have seen so far is we have started structure, and I've shown you that structures are collection of data member of related under one name. For example, only I just showed you the case of marks of a student, and as well as also detail of the student. Okay, the data might be also similar, as well as also the data can be dissimilar also. But if the data are related to one entity, then that can be taken as a structure. Then followed by that, we have seen four things: defining a structure, size of structure, declaring a structure, accessing the member. How to define a structure? You mention the keyword called struct, followed by a name given to that structure, and you open a curly braces, close a curly braces. Whichever coming inside is a body of the definition, and inside the body of the definition we have to specify the data member. What is data member? The members that are related to this particular entity called as rectangle. Then we wanted a semicolon at the end of the definition, so definition part is over. Then coming to the size of the structure, we simply said that sum of the size of each and every data member together is called as the size of this entire structure. So the size of this first member is 2, size of the second member is 2, so adding both these 2 we will get 4. So the size of structure will be 4. Then coming to declaring a structure, then comes here. So similar to integer, struct rectangle also becomes a data type, independent user defined data type, and we are specifying the data type, and we are declaring a variable called R. So once you declare a variable, what will happen? I showed you here that a memory will be allocated like this, and one block is having. So how many block will be allocated? How much member I am having, that many block will be allocated. Okay, inside this block 15 is stored. It means integer means 2 bytes. So inside this block is of 2 byte, this block is of 2 byte. So such a memory is allocated, and this memory block is given the name called R, and it is having two member called length and breadth like this. Next, what is the next one? Accessing the member. How to access? Using the dot operator. So the variable dot the member. So this is a way how you have to access the member of a structure. So two way of declaration and assignment is there. One thing, you can declare it independently, and the subsequent line like this you can make initialization, or otherwise like this you can give the declaration and the initialization in the same line itself. Okay, So far this much thing we have completed. So in the next video, which is coming in 5 minutes again. Okay, so now I think we started the first session by 10 o'clock and it finished by 10:40, and now again 10:45 we started this session, and this session has went up to 30 minutes, 32 minutes of time. So automatically what will happen now, 30 minutes in the sense it is like 12:05 or 12:10 it will be finished. So what we will do is again from 12:15 we will start the next session. So from again 12:15 we are going to start the next session, and in the next session we will be seeing few examples. We will take few examples and we will define a structure for all those examples, and also we will see how to convert structure array. One more concept called structure array is there, where the structure variable itself will become an array. Okay, so we will see about that. That might be confusing now, but we will see that in the next video. So we will see that, and in the next lecture we will also see about pointers, the introduction to pointers. Okay, see why we require all these things is that I am going to teach you function. If you need to understand function, then you need to understand the basics of arrays, only the basics of array, and you have to know the basics of structure, and also you have to know why pointer is required, what is pointer, and how it is going to work. So when basics of three concepts are over, then we can get into function and we can understand many things about function. Okay, we have not finished array, we have not finished structure, we have seen only the basics of it. Okay, so in the next session we will see a little bit more about the structure, and we will just see about pointers, and once pointer is finished we will just go to functions and we will just finish functions. Okay, so once we finish functions, then we can start fresh from array and we can convert array into abstract data type. That we will see later what is abstract data type, everything. Okay, so we are having a flow actually, right? Okay, so this flow might be different, but this is the right flow for you to study. Okay, fine. So hope I'm not teaching you anything. I'm just teaching you the concept, and if I'm teaching a structure, then all the prerequisite which is required to learn structure I could have finished it in the prior video itself. Okay, if array has to be taught, then the prerequisites of array will be completed. So similar to that, if I have to teach a function, then all the prerequisite required to teach function has to be taught, right? So that only I'm doing now. So I'm teaching you the things that is required to make you understand functions better. Okay, fine. So this is it for the session. So please keep watching. Okay, thank you.